Welcome to today's lesson, which is about solving equations and representing situations with equations. The goals of today's lesson are that you can solve equations that have whole numbers, fractions and decimals, and that you can explain why different equations can describe the same situation. So first, let's look at something called inverse operations. And inverse operations are operations that undo each other, or operations that cancel each other out. And so, for example, addition and subtraction are inverse operations. If you had no money and you earned $20 babysitting, and then you spent all of the $20, you would be back to no dollars, because earning the $20 and spending the $20 cancel each other out. Plus 20 and minus 20 are inverse operations. Similarly, multiplication and division are inverse operations. They cancel each other out. So if I had, let's say, 10 multiplied by 5, I'd get 50. But then if I took that 50 and divided it by 5, I'd be right back to 10. Because multiplying 5 by 5 and dividing by 5 are inverse operations. And we're going to use this concept today. So solve this equation using an inverse operation. And you saw how we solved equations like this with balance hangers, where we had x and some numbers on the left. I'm going to quickly draw 1, 2, 3, 4, 5, 6, 7. And on the other side, I have 10. And this balances like this. And if I want to solve this with the hanger, I can match up 1, 2, 3, 4, 5, 6, 7, and I am left with x equals 3. There are 3 that had no match, because I have to take away the same amount from both sides. Well, I'm going to use inverse operations to do the same thing. I want just x on its own at the end. After solving my equation, I want x equals, that's called isolating x. And so I've got to take away the same amount from both sides. So I'm going to take away 7. I'm going to subtract 7 from both sides. Subtracting 7 is the inverse operation of adding 7. So here we have our inverse operations. So when I take away 7 there, I'm left with 0. X plus 0 equals, and on the other side, I'm taking away 7 as well. 10 minus 7 is 3. And we don't have to say x plus 0. That's the same as x. So x equals 3, which is what we got with the balanced hanger as well. Now let's look at subtraction. What would our inverse operation be here? The inverse operation for subtracting 5 is adding 5. So I'm going to add 5 here, and I've got to add it to both sides to keep the equation balanced. And I end up with x equals 7. This also works if we have decimals. On the right hand side, we have x minus 2.5 equals 3.25. And first I say, what's my inverse operation for this minus 2.5? It's plus 2.5. And remember, you've got to add it to both sides. So let's do that. On the left hand side, minus 2.5 and plus 2.5 cancel each other out. So I'm left with x equals, And on the right hand side, 3.25 plus 2.5, I'm going to put a 0 here. So 5 plus 0 is 5, 2 plus 5 is 7, my decimal point, and 3 plus 2 is 5. So x equals 5.75. So the solution to that equation, the number that makes it true, is x equals 5.75. Now let's look at this one. 2x equals 10. And really what we have here is 2 multiplied by x equals 10. And remember that the inverse operation of multiplied by is divided by. So I've got to take my 2x and my 10 and divide both of these by the same thing. Divide them both by 2. And 2 divided by 2 is 1. So I'm left with just x here, and 10 divided by 2 is 5. So we've used the inverse operation of division, and we've got a solution of x equals 5 that makes the equation true. And here we have x divided by 4 equals 20. And what's our inverse operation for divided by 4? It's multiplied by 4. So we are going to have 4 times x over 4 equals 4 times 20, because we've got to do the same operation to both sides, perform the same operation on both sides. And 4x divided by 4 is 1x, and 4 times 20 is 80. So 80 is the solution to this equation. It is the number that makes it true. So let's write an equation to represent a situation. We've got Tommy collected 6 fewer pieces of candy on Halloween than his friend Jonah did. If Jonah collected 18 pieces, how many did Tommy collect? So I'm going to start off by defining my variable. Let x equal how many pieces Tommy collected. And I'm going to say x is equal to Jonah collected 18, and if I subtract 6 from that, because he collected 6 more than Tommy, that would tell me how much Tommy got. Also, I could write the equation like this. Tommy got x, or he collected x pieces of candy. If he had only collected 6 more, he would have the same as Jonah, which is 18. So those are 2 different equations for the same situation. When you solve them, you'll get the same solution. X equals 18 minus 6. 18 minus 6 is 12. And in the one here at the bottom, x plus 6 equals 18. Let's use an inverse operation of minus 6. And we'll get x equals 12. So both equations are correct. It's just how you look at it. So you saw today that addition and subtraction are inverse operations. Multiplication and division are inverse operations. So you can solve equations that have whole numbers, fractions. You saw x over 4. And you saw one with, I think it was 2.25, and our answer was 5.75, so you worked with decimals. And you saw why different equations can describe the same situation. And that's the end of today's lesson.